Hi everyone, this is Satya Priyan, Physics faculty from E4U. Today we are going to discuss about electrostatics. That is, we are not going to discuss the content. Again, we are going to discuss only the important multiple choice question which is related to this topic. Hope you have studied the formulae many times from the electrostatics as it is the first lesson in your 12th standard. Directly we will go for the first question. Two equally charged identical metal sphere A and B repel each other with a force F. The spheres are kept fixed with a distance r between them. A third identical but uncharged sphere C is brought in contact with A and then placed at the midpoint of the line joining A and B. The magnitude of the net electric force on C is. Okay. So, first of all you can take, there are two charges, we can able to write it as, take it as A and B, and they are having the repulsive force between them because they both are, we can able to take the same similar charges. I am assuming this nothing but Q, and the spheres are fixed with the distance r between them, so we can able to fix the distance between them as nothing but r here. But uncharged sphere C is brought in contact with A first, so I am going to brought in contact with A and then placed at the midpoint. Okay, so suppose I am going to have the C and A with contact with each other, it's uncharged charge, so that the second sphere C is not having any charge and the first sphere C alone, A alone is having the charge. So, whenever I am connecting two spheres, the charge will be equally distributed between them, so that at last the charge will become Q by 2 and Q by 2 between them. So, here I am going to keep the third charge with the value of what? Q by 2, and it's also having the charge of Q by 2. And it's having the charge is nothing but Q only. Okay. Initially the force is nothing but force between A and B, that's nothing but F is equal to FAB is equal to F is equal to, because in the question they given it's nothing but F K into Q square divided by distance between them is nothing but R squared. Now I want to find out the force between A and C. Okay, they ask the magnitude of the net electric force acting. So, FAC or FC you can take the net force acting on a particular charge C, what we kept at the midpoint. Okay, so we can able to take, that's nothing but force of FAC, and you can able to see that both the things are nothing but repulsive force only, so that they will act in the opposite direction, so that we can able to go with the subtraction between them. FAC minus you can able to take it as FBC. Okay, so now I am going to find the force, and which will be greater. Actually it's having the charge is nothing but what? Q by 2, and it's having the Q, so that I am going to take this is plus and this is nothing but minus, so that the force here is nothing but K into, both are having the Q by 2, so I can able to write Q square divided by 4 divided by distance between them. Now it's nothing but only R by 2 the whole squared. Similarly minus sign I can include here. Here what I will get? It's nothing but FBC. What is the FBC value will get? Q square divided by 2 divided by distance between them is nothing but R by 2 the whole squared. So now I can able to take the common quantities out. If you take the common quantities, I can able to take K Q square divided by 2 divided by R by 2 the whole square into minus 1 by 2 plus 1, that is equal to, you can able to get it as K into Q square divided by 2 into R square divided by 4. If you subtract, you will be getting, it's nothing but 1 by 2. Okay, so I can able to cancel 4 and everything will be cancelled. So again you will get K Q square divided by 4, then you will be getting the same force. So the correct answer is nothing but option A. We will go for the next question. Two spheres A and B of radius 4 centimeter and 6 centimeter are given charges 80 microcoulomb. So I am taking the radius of RA is nothing but 4 centimeter and radius of RB is nothing but 6 centimeter, and the particular charge given to A is nothing but 80 microcoulomb and QB is nothing but 40 microcoulomb. If they are connected by a like a fine wire, the amount of charge flowing from one to another we have to find out. Actually when I am connecting it, the charges will be transferred from one part of the system to another part of the system according to the law of conservation of charges, right? Okay, so here I can able to take the consideration, that's nothing but I want to find out the Q QA after mixing, right? So now initially the total charge is nothing but QA plus QB. You can take it as Q, that is equal to 80 plus 40, 120 microcoulomb. 120 microcoulomb. So I want to find out the QA, that is the particular charge present at last. Simply you can remember, I can able to go with the potential divider rule here. That's nothing but like charge divider rule. QA is equal to total charge into same radius divided by sum of the radiuses. Sum of the radii. So total charge is nothing but 120 microcoulomb. So 120 into 10 to the power of minus 6. Ra is nothing but 4 centimeter, and 4 plus 6 10 centimeter. Then what will get? Centimeter will be cancelled out, and I can able to cancel, it's nothing but 2 by 5. So you can able to divide it. When you divide, what will get? It's nothing but 24. 2 into 24 is nothing but 48 microcoulomb. Actually now the particular charge QA is having only 48. Then what is the meaning of this? There is a 32 microcoulomb has been travelled from A to B. 32 microcoulomb has been travelled from A to B. Okay, we'll go for the next question. The charges on two spheres plus 7 microcoulomb and minus 5 microcoulomb respectively, they experience a force of F. Okay, so we can able to take two charges. It's a third question. Plus 7 microcoulomb, and we can take with minus 5 microcoulomb. Okay, and it's given with they are separated by a distance something. You can take it as R. In the time the force is nothing but F. Okay, now we are going to give additionally minus 2 and minus 2 for both. When I am giving minus 2 for this, you know that law of additive nature of charges, so that you will be getting minus 2 plus 7, it's nothing but plus 5, minus 5 minus 2 is nothing but minus 7. Okay, so whatever it may be, the magnitude is not going to change, right? Okay, because 7 and 7, 5 and 5 are interchanged, that's all. But so that you will be getting the force is nothing but the same force for the after transition or adding of charges also, the force is not changing, so you will be getting the same force. Kindly take down this. The next question, we'll go for the fourth question. If charge Q is placed at the center of the line joining two equal charges Q such that the system is in equilibrium. Okay, so we can able to take that if charge Q is placed at equal charges. I'm going to take two charges. It's nothing but plus Q and plus Q are equal charges. We are going to keep the one more charge at the center. We are going to keep one more charge at the center, but even though we are going to bring one more charge to the center point, the particular equilibrium position should not change, right? Okay, so that the force acting on this will be equal to this, then only I can able to take. And very important, the force, these two, if you take positive charge, this must be negative charge. I am taking Q, and Q is nothing but positive charges, then minus Q must be negative charge to get it. Okay, so that I am going to take it as Q is equal, like we will go with the force, the electric field, whatever it may be, we will take with the force between them. So the force on, like first A and B you can take, this nothing but C, force between A and B plus force between A and C must be equal to what? 0. Then I can able to write it's nothing but K into Q square divided by distance between them. Initially you can take it as R between them, then this distance is nothing but R by 2. So in is nothing but R squared plus, here what I will get? K into Q into small q divided by R by 2 the whole square is equal to 0. So I am going to take this to this side. If you take it, you can K into Q divided by R by 2 the whole square is equal to K Q square divided by R squared. Very important, I am bringing one term to this side, we have to add the negative sign, right? Okay, so K Q square will be cancelled out, and R squared will be cancelled out. 1 by 4 if it comes to this side, Q is equal to minus Q by 4. Okay, this is the correct answer. We will go for the next question. Next question. 4 charges equal to minus Q are placed at the 4 corners of a square, and a charge Q is at center. If the system is in equilibrium, the value of Q is. Okay, so we will take the consideration, that's nothing but I am going to consider 4 charges are kept at the 4 corners of a particular square. Okay, we will take, so a square of side we have kept minus Q, minus Q, minus Q and minus Q, and I am going to keep one more charge here also. The charge is what? Plus Q. Okay, whatever it may be, the system must be in equilibrium. That is the thing we have to take. Must be in equilibrium means the same way what we have taken for the 2 charges with 1 charge, here we are going to go with 4 charges with 1 charge at the center. Okay, so I can able to say that we will take one with respect to this charge, you can take it as A, B, C, D as the points, and this center point I am going to take it as O. And the side they given as in the problem, the given side is equal to, okay, the side they didn't mention, right? Okay, so I can able to mention anything, it's nothing but what? A I am taking. I am taking side is nothing but A. So with respect to this, okay, we can able to go with potential, or you can take it with the electric field, or you can go with force. Okay, we will go with the force concept. Force concept means, similarly you can able to add all the 3 charges what is acting on the 4th charge and also this charge. Okay, then you can equate to 0, so that you can able to get the answer. Okay, if you solve with the similar method, you can able to get the answer for the 5th question. We will go for the next question. Copy down this. We'll go for a sixth question. That is, a charged ball B hangs from silk thread S, which makes an angle theta with the large charged conducting sheet. Okay, so we can able to draw the diagram once again here, whatever is given in the thing. Okay, it's nothing but a particular thin plane sheet. Okay, so here I'm going to consider the ball is acting. Okay, it's acting with a particular mass of what you can take it as mg, and the tension will be acting here. I can able to split the tension into two parts. This is nothing but T. If it is theta, then this will be theta, right? Then this will be T cos theta, and this is nothing but T sin theta. And here some force is acting. That force is nothing but electrostatic force. You can take it as F is equal to Q into E, right? Okay, they ask us to find out the sigma. Okay, so I can able to take the force is nothing but F is equal to QE. The Q can be written as sigma into A into E for a particular. Otherwise, for a charged sheet, I can able to take Q, you can take as it is, F is equal to, I can able to write E is nothing but sigma divided by 2 epsilon naught into Q, right? E is equal to sigma divided by 2 epsilon naught. Okay, I can able to equate both the thing. If you divide both the thing, what I will get? I can divide like a T sin theta is equal to, I can equate to F is equal to QE. Similarly, T cos theta is equal to mg. Okay, so I can able to divide both the thing. If you divide, you will get tan theta is equal to QE divided by mg. Here Q into E is nothing but sigma divided by 2 epsilon naught divided by mg. So I want to find out sigma. So sigma is nothing but mg into 2 into epsilon naught tan theta divided by Q. Actually here m is constant, g is constant, epsilon naught is constant, Q is also constant. Then sigma is directly proportional to tan theta. We'll go for the next question. In a uniformly charged sphere of total charge Q and the radius R, the electric field E is plotted. Again, see, you can take uniformly charged sphere means the particular charge has been filled fully. So with respect to center, I want to find out the particular electric field outside, and also you can take it as on the surface and also what inside at a particular point. Okay, actually in the 11th standard you might have studied the topic called gravitation. In gravitation, if you measure it, you can able to get the curve like this. That means with respect to center, center can be taken as what? Origin, and this is nothing but what? A particular radius. This distance is equal to what? Radius. We are going to draw the graph between distance versus electric field E. Okay, so now the particular curve will be keep on increases because inside the sphere the E is directly proportional to R. But outside we know that E is equal to 1 by 4 pi epsilon naught. Suppose I am going to take total charge is nothing but Q divided by small r square. Small r is the distance. This you can take it as a point P. Okay, so now it's nothing but E is inversely proportional to R squared. Inversely proportional, you know that it will be keep on what? Decreases. Okay, so we can able to get, and very important, it is 0 and it is nothing but R. The electric field intensity due to a solid sphere will be maximum at its surface. Okay, and it will be keep on decreases when you are moving away. Okay, thank you.